All right, our next unit is going to be on chemical reactions, and this is just going to go through some of the basics of what a chemical reaction is. So a chemical reaction is a change in which one or more substances are converted into a new substance. All right, so when one or more substances is converted into a new substance, uh, goes through and gives several examples. You know, like we talked about, like, oh, sodium and chlorine, when they bond, they form table salt, sodium chloride. Well, this is just talking about that process, where you have sodium as an individual element and atoms, and chlorine as individual. Well, when you combine them, that process of that combination is the chemical reaction. And so we've talked about, like, oh, when you combine these things, this is what happens. But we're going to actually put an official name to it, and that's called the chemical reaction. There's parts to a reaction. And pretty much every reaction is going to look something kind of similar to this, where it's going to have an arrow to show that a reaction has occurred and produce something. Right? That arrow means produces. Sometimes it'll be referred to as yields. Um, but that arrow signifies a reaction has occurred. All right, and so anything left of the arrow are your reactants, and you can just write them exactly as they show up. All right, so anything left of the arrow, this is kind of before the reaction has occurred. This is what we have. And then this arrow indicates, hey, a reaction has occurred, and what we have left is our products. And so anything before the arrow is reactants. Anything after the arrow is our product. And so, like, and it can be more than just one thing. Like, for example, if I said, uh, sodium and chlorine, when you add sodium to chlorine, you get whatever, table salt, whatever. If you add baking soda to vinegar, you'll get a new substance plus hydrogen, or excuse me, carbon dioxide gas being released. And so, but this is maybe a little bit simpler way to put it. When you combine two elements and they react, the reactants are going to react. Right, the reactants will react, and that's what this arrow, remember, that means something new is going to be produced. And over here is what is being produced, the products. Not too tricky, hopefully. All right, a guy that is going to be pretty important for what we talk about, because we're going to talk about balancing chemical equations. You got to make sure both sides of an equation are balanced, both the reactants and the products, both their mass and the number of atoms. Because we're not magicians, all right? We're not going to just make things magically appear and disappear. So we want to make sure both things are the same. And so that's what Lavoisier discovered. So he discovered the mass of the product is always equal to the mass of the reactants. And that's called the conservation of mass, which is the title of the slide. Conservation of mass. The mass is always conserved. It can get converted from one form to another, but it's always conserved. Even if you put things on a scale, if you put baking soda and vinegar in separate beakers, the mass after you mix them would be different, because what happens is carbon dioxide gets released. And so the mass might be slightly lower, but that doesn't mean the mass, like, oh, when baking soda and vinegar mixed, the mass just disappeared. No, it's just converted into a gas. And so that's basically what Lavoisier talked about with his conservation of mass. That's his main contribution. I'm not going to go into the specifics of it, but there's the specifics. Known today as the father of modern chemistry for describing a combination of chemical reactions called combustion. Writing a chemical equation. A way to describe, once again, a chemical descriptor is a way to describe chemical reaction using chemical formulas and symbols. And so when we write chemical equations, we are going to use some of these symbols. All right, you're going to have to know what these mean. These aren't like too crazy, but once again, the arrow means something is being produced or formed. The plus sign means plus. You're combining two or more substances, either elements or compounds. And then it's pretty simple after you look at so for example, if I had, like, let me put on here, this would be an example. I'd have hydrogen gas, G plus oxygen. Yes. Produce, and for the sake of keeping this as a balanced equation, I'm just going to put H2O2, and it's a liquid. All right, and so really what this is saying is I've combined hydrogen gas and oxygen gas to produce H2O2, which is peroxide in a liquid. And so, but you can see I have, when I write these forms, and I'll probably give you some word problems where I'll say, write this out. This combined with this to produce this in a liquid state. You're going to have to make sure you put the parentheses. If I give you the state of matter, the parentheses, it's the state it's in. Make sure that you put the arrow in the correct spot. Make sure you add a plus sign when it's combining. And we'll get into coefficients here in a minute, but that as well. And an aqueous solution, if I say so-and-so, something dissolved in water, that's what aqueous means, that AQ. It means it dissolved in water. It's an aqueous solution dissolved in water. All right, so law of conservation of mass, once again, and we're going to go into this a ton. A big part of what we're going to be learning is how to balance equations, making sure that both sides are equal. And so really what it's saying is that chemical reaction, matter is not created or destroyed. Atoms can only rearrange. So you have to have the same number of atoms on the left side of the arrow as you have on the right. All right. I oftentimes, when we get into this, we'll get into this in more detail. I say that this arrow is a mirror and it needs to reflect each other. Or you can think of it like an equation. If I've got 2 plus 2 equals 4. Well, really, what's that equation saying? Both sides of the equation are equal to 4, right? Because on one side I got 2 plus 2, well, that's 4. And then on the other side I got 4, which is the same thing as 2 plus 2. And so both sides are equal. And so when you look at a math equation, what it's really telling you is that both sides of this equation are equal. It's going to be the same thing with chemistry. Both sides of this chemical formula, we want them to be equal. Now you can rearrange it and you can make it look different, much like 2 plus 2 is 4, but we want it to be equal. Both sides of the equation to be equal. So you can think of it like math if you want. And so here's a situation where it says aqueous lead-2 nitrate plus 2 units of aqueous potassium iodine. All right, so let's just look at this really quick. All right, so 2 units, and you won't know this stuff. Some of this is a little bit more advanced than we'll do. But lead-2 nitrate, that's what that is, in an aqueous solution. So aqueous lead-2 nitrate. Don't worry about the lead-2. That just tells you that's that number right there. And then it says 2 units, produce 2 units. A unit is going to be a coefficient. We're going to be using these. We cannot add, in order to balance subscripts, we're not going to be or to balance atoms, we're going to use these things called coefficients. All right, and it's the number of units of each substance. All right, coefficient's going to be very important. All right, because like I said, we're not going to, in order to balance both sides of the equation, we're going to use coefficients a ton. And so understanding what they do, basically it's saying that there are 2 units of Ki. So it'd be like just writing Ki twice. If I could do it, I would. So 2 units potassium iodine bonded together. All right, there's 2 of that compound. If it was 2 of, I don't know, Na, there'd be 2 sodium atoms present. All right, so 2 units of sodium atoms. So these coefficients are going to be used pretty frequently, and they're called unit managers. All right, but this is the kind of problem, it'll be simpler than this, but this is the kind of problem you're going to have. I'm going to give you a word problem, and you're going to have to do that. Describing coefficients, individual atoms. So if you see a coefficient in front of like 2 Mg, that means there's 2 atoms of magnesium. All right. If you see something like 3, coefficient 3 in front of CO2, that means there's 3 molecules of CO2. So it'd be like CO2 is occurring 3 times. All right, so there's 3 units of that. Same thing with the ionic substance. So if you have magnesium oxide, there would be 4 units of that. All right, so same kind of idea. All right, but once again, we're going to be using this a lot when we talk about balancing equations. Metals in the atmosphere. I don't know if we're going to talk about this much. Yeah, we're not going to talk about iron oxide, and I don't think we're going to even bother talking about this. Aluminum. Yeah, we're going to skip this. Anyway, we'll stop there. Those are just the basic parts. So when you're writing a formula, once again, the basic parts of it, going through lead nitrate plus this produces once again, that produces will be there. And then there's the new substance lead iodide, lead 2 iodide, which is in a solid state, plus in 2 units, there's my 2 units of potassium nitrate in a aqueous state. All right, and so you're just going to have to follow along. We'll get practice at it if it's a little bit confusing, but you just go right along and write it as you go. All right, that's the basics of chemical equations.